Dear friends, today I will discuss with you how we can find magnetic field at a point on its axis due to a current carrying loop. You know, this is a circular ring. Okay, some current is flowing, maybe clockwise or anti-clockwise. Then you know very well when current will flow maybe clockwise or anti-clockwise, then it will make a magnetic field. Our problem is, what is magnetic field? At a point on the axis, this is axis. And what is the field at here, at this point, at the tip of the pen? Okay, what will be the magnetic field in magnitude and direction? Now, this is the ring. No? The ring may be placed like this, or maybe it is placed like this. So I am placing it like this, in this way. I am placing it like this. Okay. This is my circular ring. Okay, like this. And this is the axis of the ring. This is my observation point where I wish to find the magnetic field. From the center, the distance is x. Let the current is flowing like along this direction. I consider a length element, or you can see current element, and this current element is I into dl vector. Okay. The radius of the ring is I call it small a. Now this is the current element, this is the observation point. Now what is the distance of the observation point from the current element? Let this distance is our r. I am using Bart's law for writing small magnetic field because of this small current element. And what will be that? That will be dB equals to mu naught upon 4 pi, mu naught over 4 pi IDL sine theta upon r square. It is in magnitude. You should also know a formula in vector form. In vector form, the formula is mu naught over 4 pi I dl vector cross r cap upon r square. Okay, this is in vector form, this is in magnitude. Now what is the sine theta? Or you can say theta. Theta is the angle between dl and the r vector. But the problem is what this angle is between IDL and R. Okay, it is not clear because this picture is two-dimensional So just I try to explain you, like this is an axis and this is a ring. This is our r vector. The current element is like this. This is the current element. Okay, this is the current element, right? This is the axis. This is r vector. The current element and the r vector. What is that angle? That angle is this one. This is 90 degree. If let this position point P is here, even then the angle is 90 degree. If like this, even then the angle is 90. The point may be here, maybe maybe at this point, maybe at this point. This angle remain 90. Okay, between R, this is R, this is TL, and this angle is 90. Okay, I'm changing point, but angle remain 90 degree between DL and R. So theta remain 90. So here it is sine 90. What is sine 90? 1. So it becomes mu naught over 4 pi I dl sine 90 is 1 upon r square. Now what is r? If this angle is phi, what is the value of r? r is equals to this is Pythagoras theorem, under root of a square plus x square, under root of a square plus x square. So in magnitude the formula becomes dB, it is mu naught over 4 pi I dl upon r square, mean a square plus x square, because this is power half and square cancels. Now we coming, what is the direction of the dB? Now the direction of dB mean it is perpendicular to this plane in which dl and r lies. So this is dl and this is r. Like this is dl, this is dl, this is r. Okay. Now what is the direction of dB? It is perpendicular to this plane. This is dl, this is your r, and this becomes a plane. Okay, and perpendicular direction, field will be perpendicular to both dl and as well as to r. Perpendicular means like this. You just think perpendicular to this line, it is like this. Okay, dl, this is dl, this is r, this is one plane, and perpendicular like this. Okay. So the direction of field will be perpendicular to this line. So it will be like this. Okay. Now I resolve the dB into two components. One component along this side, one component along the axis. Now the problem is, what is this angle? If I produce this line, if I produce this line, if this angle is phi, this will be phi. And you know, this line is perpendicular to this line. So if this angle is phi, this angle will be 90 minus phi. Now coming here, this total angle is 90 degree. This angle is 90 minus phi. What will be this angle? It left phi. Okay. Then if this is dB, this will be dB cos phi. And this will be dB sin phi. Now similarly now coming, because we are not here, we are not having only one current element. You know, along the ring, along this loop, everywhere, you know, continuously there are the current elements. Okay, let I consider this one, this current element, exactly opposite to this. Again, I'll try to find the magnetic field at here because of this element. So I will join this line. Okay. Then the direction of the magnetic field in magnitude will be the same, this value. But the direction will be perpendicular to this line. Like this, dB. Again, I will resolve this dB into components. And what are those components? One component along this side, second component again along this side. This angle will be again phi, as I already explained. This component will be dB cos phi. This component will be dB sin phi. So dB cos phi and this dB cos phi will cancel out. But dB sin phi, they are along the same direction and they will add. Not because of these two elements they are adding, they will add because of all the current elements which are continuously on this loop. That means total magnetic field will be integration of what? dB integration of this component all along the loop, dB sin phi. dB sin phi integration all along the loop. So substituting here the value of dB, so P becomes mu naught over 4 pi I dl upon a square plus x square. Then I am having sin phi. Now what is sin phi here in this triangle? Sin phi is perpendicular upon hypotenuse in magnitude. Okay, that means sin phi is perpendicular. What is perpendicular? A upon magnitude of r, which is root of a square plus x square. A square plus x square root mean power half, and integration of this. Because integration is over for the complete length of the loop, only the integration will be with respect to length. So the P becomes mu naught over 4 pi I upon a square plus x square raised to power 1 and half, 3 by 2. Then it is A, and integral of dl means total length of the loop. What is total length? Circumference of the loop, which is 2 pi A. So it is here 2 pi 2 pi a. Okay, and a, so it becomes a square. So this is the total field. Now one thing more, pi a square. Remember what is pi a square? You know, pi a square is the area of this loop. Okay, now the form. So we are having that formula of P, magnetic field at a point on the axis at a distance x from the center. And rewriting this formula again, B is equals to mu naught upon 4 pi I to a square plus x square raised to power 3 by 2, and then pi a square. Now what is pi a square? Pi a square is the area of this loop. So this becomes, B becomes mu naught upon 4 pi I to a upon a square plus x square raised to power 3 by 2. What is current into area? Current into area is magnetic moment. You know, we are having a circular loop, current is flowing. When the current flows through the loop, it behaves like a magnet. If it behaves like a magnet, it must have magnetic moment. And what is magnetic moment? Current into area. And unit of magnetic moment, ampere meter square. So B becomes mu naught upon 4 pi to IA mean magnetic moment a square plus x square raised to power 3 by 2. This is the exact formula for magnetic field at a point on the axis. Okay, at a point on the axis at a distance x. Now, if you may think, now one thing it is clear, as x go on increasing, you increase the value of x, this will go on decreasing then. It will decrease with increasing x. Now there is another point. If you are coming closer and closer, if you are coming closer and closer, and what happened at the center of the loop? At the center, x becomes 0. X becomes 0 at the center. So, at center, x is 0. Two, magnetic moment is current into pi r square. And x is 0. Mu naught over 4 pi 2 pi I upon a square cancel with cube and left only singly. So this is the magnetic field at the center of the loop. Okay, at the center of the loop, the field is maximum because there is no x and it is a constant value. And if the excess there, the field will decrease and go on decreasing with x. So I can say this is the field B maximum, then go on decreasing with increasing x, increasing x, go on decreasing with negative x. And but at the center, the value is maximum. How much? Mu naught over 4 pi, 2 pi I upon A. Now, if your point is, we are having a coil, we are having a loop of many turns, n turns, then what about the expression? Very simple. Only here comes n. If there are the n turns. For n turns, this is the magnetic field, and M is the magnetic moment. Okay? So this is all about the magnetic field due to current carrying loop. One point is, one may be this point. If you say x is very, very much greater than small a, mean your observation point is far away from the loop, then okay. Then you put here a equals to 0. A0 in comparison with x. Not put A0 here from the magnetic moment. You can put A0 in comparison with x, because x is very much greater than small a. Then formula becomes B are very far away from the center of the loop. Mu naught over 4 pi n to m upon. Here you know what a equals to 0, x2 and 3 by 2. So here comes the x cube. So this is our last formula. If observation point is far away from the center of the loop. So remember now, remember one thing, if you are having a loop, current is flowing, then it exactly behaves like a magnet. Okay, now if this is a coil and current is flowing, okay, then its one end, if the current is flowing, then its one end behaves like a north pole and other end behaves like a south pole. It becomes a magnet with north pole and south pole. But then you may ask whether this phase will be north, this will be north or south. How we say? What about this phase? Whether it is north or the south pole? Okay, very simple. You know, if you look the coil from the upper side, from its face, from the face, if the current is flowing anti-clockwise, okay, if the phase, you look the loop from its face, you look the coil from its face. If the current flowing is anti-clockwise, anti-clockwise mean like N and arrow, join the arrow. This is anti-clockwise. Anti-clockwise direction, then this phase becomes north, and from below it will be the south. And if you are having a loop and current is flowing clockwise direction, then S, put arrow. Okay, arrow mean clockwise current. Like if the current is clockwise, the phase becomes south, it behaves like a south pole, and from below it will be north. Remember, for to know about north, you put arrow, anti-clockwise mean north, and south put arrow clockwise, then behaves like a south pole. Okay, this is all. Thank you very much.